Till now, we have learned 4 types of traversal and we have implemented them in practice. Now in this lecture, we will talk about searching for a node in a binary tree. So let's say we have a binary tree like this and we want to search for the value of n5. So in this case, we know that n5 is located in this binary tree over here. So the idea is very simple. All we have to do, we have to traverse through this binary tree over here and check that if this n5 is located in any of these nodes over here. So if any node's value is equal to n5, it means that n5 exists in this binary tree over here. And here, if any node matches the value that we are looking for, then we simply terminate the traversal because we don't need to traverse the tree anymore. So in case after searching all elements, if we cannot find the element, we return a message saying that the value does not exist in this tree over here. Now here we are going to use traversal. But here the interesting question is which traversal we are going to use in case of binary tree for searching operation. So in this case, we are going to always use level of the traversal because when we are discussing about the traversals, in case of all other traversals, we have used stack, but in case of level of the traversal, we have used queue. So we know that queue always performs better than stack, so that's why we will use level order traversal for searching operation in this case. Now let's see how this is working in case of this binary tree over here. So as I mentioned, we are going to use level order traversal. So in case of level order traversal, we are traversing through all levels and visiting all nodes. So in this case, we are going to visit all nodes and check that if visited node's value is equal to the value that we are looking for. So in this case, we are going to terminate that. So here we have levels like this. So first we are going to start from the first level. So is this the node that we are looking for or not? So in this case, the value of root node is n1, but we are looking for the value of n5. So this means that we are going to continue to the next level. So in the next level, the first element is n2. So we are going to check that if n2 is equal to n5 or not. So we see that it's not equal. So this means that we are going to continue to the next element. So in the next element, we have n3. So this is not equal to n5. So this means that we have successfully completed level 2. So we are going to continue to the level 3. So in the level 3, the first element is n4. We are going to check that n4 is equal to n5 or not. So we see that it's not equal. So this means that we are going to continue to the next element. So in the next element, we have n5, which is equal to value that we are looking for. So this means that we are going to stop over here. So in this case, we are going to return success message saying that this value exists in our binary tree over here. Now by using this logic, we are going to create a search method using level order traversal in practice. So let's head over to Java, create the method over there. Now here, after level order traversal, we are going to implement search method. So in this case, our search method will not return anything because in this case, we are just going to print out to the console that if we have found the value or not. So the method will be like this, public void. So I'm going to name the method search. And the value that we are going to look will be the type of the string, because when we are creating our binary node over here, we have set the value as a string type. So this means that I'm going to create a method which takes string value because we are going to look for a string value. Now inside this method, as we mentioned before, we are going to use level order traversal. So in case of level order traversal, the first thing that we are going to do, we are going to create queue. So this queue will be the type of binary node. So I'm going to name it queue, and it's going to be created using linked list. So it's going to be binary node. Now with this, we have successfully created our queue over here. Now the next step is we are going to add root node to this queue over here. So we're going to add root node. Then after adding it, we are going to loop through the all nodes, starting from the root, then left, and then right subtrees. We are going to enqueue the elements to this queue, and we are going to dequeue them one by one and check that if the value of the node is equal to the value that we are looking for or not. If any case it's equal, in this case we are going to stop the loop over here, otherwise we are going to continue until the end. So I'm going to write if condition like this. If queue is not empty, in this case we are going to create a new node, and this node will take the value that comes out of the queue data structure from here by using the queue method. So in this case, we are going to use remove method. So I'm going to create a binary node. So in this case, it will take queue remove. So this method removes the first element from queue and returns that element. So we are going to save it to the present node. Now, after doing so, as you remember, in case of level order traversal, we were printing out the value of present node to the console. But in this case, we are not going to print out value. We are going to check that if this value is equal to the value that we are looking for or not. So in this case, if condition will be like this. If present nodes dot value is equal to the value that we are looking for, in this case, we are going to print out to the console that the value is found in the tree. So I'm going to put it like this, system out print the value I'm just going to concatenate the value that we are getting from parameter found in tree. Now after returning message, we are going to return, because in this case we need to come out of the loop, so that's why I'm putting return over here. Otherwise, in the else condition, we are going to do the same process that we did in case of level order traversal. So we are going to check that if the present node's left subtree is not null, we are going to enqueue them to the queue. So in this case, it's going to be like this: present.left is not equal to null. In this case, we are adding left child to the queue, so I'm going to call queue.add present node.left. So same operation will be done for right child. So I'm just going to copy this if condition from here and put it over here and change left to right. So first we are adding left child, then we are adding right child, because in case of level order traversal, we have to loop from left to right. Now after doing so, at the end, when we are finishing looping, we are going to print out to the console saying that the value is not found in the tree, because in this case, if you are looping all elements and we see that we don't find the value that we are looking for, in this case we need to print out to the console saying that the value is not found. So I'm just going to copy this message from here and pass it over here. Instead of is found, I'm going to put is not found. Now with this, we have successfully implemented our method. So basically what we are doing over here, we are searching through the binary tree, and in this case we are using level order traversal and checking that if the value that we are looking for exists in this binary tree or not. So if this exists, we are returning over here saying that the value is found. Otherwise, we are continuing search. Now let's see how this is working based on the tree that we created before. So as you remember, here we have created this tree that's shown in this picture over here. Now here we see that we have an element of n5. So by using search method, we are going to look for n5. Now if I run our code, so here based on this binary tree, we are calling search method with the value of n5. Now if I run our code, so you see that we have an error in our code. So I mistyped again something over here. So it's over here, present. It should be present. So if I run our code one more time, you'll see that in this case it returns to the console saying that the value n5 is found in this tree. So we can see from this picture that the value exists in this tree over here, because when we are creating this tree over here, we have assigned n5's value to n5. Now with this, we have successfully implemented our methods. Then we have checked it in practice and we see that it's working successfully. Now let's see what's the time and space complexity for this method over here. Now here again, we are going to start from the first line of this method. Now in the first line, we are creating a queue. So this will take O1 time complexity. Then in the second line, we are enqueuing the root node to this queue over here. So this one also will take O1 time complexity. Then inside loop, we are checking that if queue is not empty, we are continuing looping through all elements of the binary tree. So in this case, if the number of elements in the binary tree is n, so in this case, it means that we have to visit all elements of the binary tree. So it means that it will take O(n) time complexity. Then inside this loop, we are creating present node and we are getting the value from the queue. So this will take O(1) time complexity. Then after doing so, we are checking that if the present value is equal to value that we are looking for, in this case, we are returning this message to the console. So this means that this if condition over here will take O(1) time complexity. Then in the else condition, we are checking that if the left node of this present node is not null, in this case, we are adding this one to the queue, so it will take O(1) time complexity. Then if the right is not null, in this case, we are adding this one to the queue also, right child to the queue also. So this one also will take O(1) time complexity. Now at the end, we are printing out to the console saying that the value is not found in this tree. So this means that this one also will take O(1) time complexity. Now if we combine all these complexities over here, we get O(n) time complexity. Because here O(1)s are non-dominant terms, so we are going to eliminate O(1) time complexity, so the time complexity becomes O(n). Now the space complexity is also O(n), because in this case we are creating a queue and we are enqueuing all elements to this queue and dequeuing them one by one. So this means that if number of elements in the binary tree is n, so we have to allocate n space in the memory, so that's why it will take O(n) space complexity. Now with this, we have come to the end of this lecture. So in this lecture, we have implemented search method in binary tree using level order traversal. So hopefully everything is clear about this method over here. So see you in the next lecture.